The section's on 7.5 and it's still under the 7.5, so this is the second video. It's called linear programming. So what we're going to do is we're going to use the first video that we learned on the graphing, shading, inequalities, and do the same thing now. On top of it, we're going to have systems of inequalities now. So, for example, if I have example 1 where we have an equation of 2x plus y is less than or equal to 10, the second equation we're going to have is 2x plus 3y is less than or equal to 12. And we're also going to have these two down here, which we're not necessarily going to graph, but this is also going to tell me is what quadrant it's going to be in. So for example, when it says x is greater than or equal to 0 and y is greater than or equal to 0, this will right here tell us what quadrant, okay? So I'm going to go a little bit more into graphing of this as well, so you'll see why. So now we have to change this equation right here. The 2x plus y is less than or equal to 12 like we learned in the first video. We want to have y by itself, so we're going to bring the 2x over on the other side of the equal sign, and you're going to get y is less than or equal to negative 2x plus 10. Then we're going to take the second equation, do the same thing. We're going to bring the 2x over to the other side, and then divide by 3 on both sides. So it's going to look something like this, so where I brought the negative 2x right here, we divided by 3 right here, and do the same thing for the 12, 12 divided by 3. Now I don't have to change the sign because remember if you're not dividing by a negative on the coefficient of y, you do not have to change the sign, but if you divide by a negative on the coefficient of y, that's when you change the sign. Not because you're minusing, because in this case we minus, then we also minus, but we did not have to change the sign. Okay? So now taking this, we're going to simplify this. The 12 divided by 3, we're going to simplify it so it's going to help us to graph. So now it turns into y is less than or equal to negative 2 over 3x plus 4. So now taking this right here, the 2, 3, 4 equations right there, right? We're going to take this and we're going to go ahead and graph it. So here we go. I have then is that negative, or y equals less than or equal to negative 2x plus 10, and then y is less than or equal to negative 2/3 x plus 4, and x is greater than or equal to 0, and y is greater than or equal to 0. So let's talk about this part right here first. So on the x and y coordinates, when I have x is greater than or equal to 0, remember x is going vertically when we graph this out. So when x is 1, x is 2, etc., we go vertically. So if x is 0, we're talking about is the y-axis right here. So on the y-axis of 0, when we say x is greater than, remember we talked about in the first video, on the vertical lines, it's all on the left or all on the right. So in this case, it's going to be all on the right-hand side because greater than is on the right-hand side. Then we also have is y is greater than or equal to 0. So y is going horizontally. So remember y is equal to 3 up here, y equals negative 7 down here. So on this right here, y equals 0 is going to be the x-axis. So on the y, when it says is greater than, it's going to be all on the top part right here. So the quadrant that both of these right here overlaps is in this first quadrant. So the solution has to be in the first quadrant. So when we graph this out right here, even if it overlaps on this second quadrant, we're not worried about that because it kind of, what this does right here, it cuts off what quadrant the solution's in. So it tells me everything needs to be in the first quadrant right here. Even if it seeps down here, we're not using that. We're only using what's in the first quadrant. Okay? So let's go ahead and graph the first one. So as we did in the first video, the plus 10 tells me where it starts on the y-intercept, which is up here somewhere in 10. The negative 2x tells me the run and the rise, so if it's 2, negative 2, we put it over 1, so that way we can run 1 and then down 2, so it's going to look something like this now. So at 10, we're going to run 1, down 2, run 1, down 2, and then on this one right here, the plus 4 again is the y-intercept. The negative 2 over 3 gives me the run and the rise, so we're running 3 and down 2. So it's going to look something like this. So at 4, we're running 3, and then down 2, running 3, down 2 right there. Okay? And then again, this right here just tells me it's in the first quadrant. So everything's going to fall under here. So now we have to figure out is where our final solution meets, where all of this right here basically overlaps each other. So we have 4 choices. The first choice is in this area, this quadrant right there, or this little quadrilateral right here, that shape right there, that's a possibility. The second possibility could be in this little tiny triangle right there, where all of the solutions meet at. Then the third choice would be in this triangle, the bigger triangle right here, where all the solution meets at. And then the fourth choice is everything after it, meaning that all of this right here can be a solution. Okay? So let's go through each one of them. We know it's going to be in the first quadrant, so all I have to worry about are these two right here and see where it overlaps. So in the first part right here, in the plus 10, which is this part right here, we're going to say y is less than or equal to. So we learned in the first video, y is less than means where does the y become less than, which is on the bottom part right here. So that means all the solution has to be down here. So that eliminates this right here choice and also in this choice right here. So now we're down to two choices, which is in this triangle or in this part right here. So now I'm going to look at the green line, and it says that y is less than, so on the y right here is less than, it's going to be everything on the bottom down here, because again, y becomes less down here, y is greater than is up here. So less than is everything down here, so that means everything solution-wise overlaps in this right here, in this spot right there. So we're going to find this and go on with that, okay? Now, if this right here was the other way, if it says y is greater than would have to be on the top, so then it would have to be in this triangle right there. But since it's not greater than, it's less than, which is down here, that means it would have to fall under here, so we would have to use then is this part right here, okay? So once we know that the solution's over here, we're going to have to find all the coordinates that it meets on a line. So for example, it meets on this y-axis right here. That's one point right there, the solution. And so that's going to be at 0, 4, so that's right there. Now you can use the calculator and trace this out. So in any parts of this video, you may have to pause and just to check to see on your calculator if it is true. So in this spot right there, it's 0, 4. The other place we have to find is this intersection right here. Basically, any lines that connect or touch, you're going to have to find those coordinates. So in this spot right there, you're going to go under second, calculate, and you're going to intersect the two different lines, and you're going to find it at 4.5, comma 1. So again, if you need a pause, go ahead and pause and find out if that's true right there. Okay? The next part is this part right here, where it crosses, because again, the solution's all inside here. So because it's all inside here, I need to find out is where is this spot right there. Now in this case, because it crosses the x-axis right here, it's going to be a 0 line. So under the second calculate, you're going to find the 0. So in that 0 right there, it's going to become 5, comma 0 right there. Okay? The last part is this corner right here, which a lot of people will forget. So this corner right there is the origin, which is the 0, 0 right there. So now using all four of these intersection lines right there, they're going to give us this thing called the feasible or the objective function, which is an equation. So with this equation, we're trying to figure out where on this point right there, any of those points of that solution, are you going to find the maximum and also the minimum. So then using this equation of f equals 5x plus 8y, because this is the x right here and because this is a y, we're going to substitute the value of x and substitute the value of y into this equation and figure out what is our number or the feasible number for this. So let's go ahead and start at 0, 4. So at 0, 4, I'm going to set it up as f 0, comma 4. Again, the 0 becomes the x value, the 4 becomes the y. So under the x value right here, we're going to substitute in 0 right there. For the 4, we're substituting in for the y right there, and we do the simplifying part of it. So 0 times anything is 0, and then 8 times 4 is 32. So our final answer is 32 at that point of 0, 4. Okay? The next point I would use then is 4.5 and 1. So do the same thing. We go 4.5 times 5 right there, and then 1 times 8 right there. Together, it comes out to 30.5. The next point I would use is this right here at 5, 0. So at 5, 0, we put in the substitution part of it. So that's 25, and 8 times 0 is 0. So the final answer is 25. And the last one is the origin at 0, 0, so obviously that's going to come out to 0. So once we're done with this part right here, we're just finding out is where is the maximum value and where is the minimum value. So the maximum value, if you look at the numbers, the final product, we have 32, 30.5, 25, and 0. So it looks like 32 is a maximum, so you'll just write down maximum at 0, comma 4. And then the minimum number is obviously the 0 right there, so 0, 0 becomes the minimum right there. Okay? So that's it for the linear part of